Welcome to statistics. Have you ever wondered where people get information such as a president has a 42% approval rating? Have you ever thought, how do we know that 1 in 10 people or 10% of people are lefty? Did a researcher collect data from everybody in the entire world and then compute that percentage and say, oh, okay, there's 10% of people in the world are lefties? Certainly not with over 7 billion people in the world. So, how do they get that information? All those types of things that we hear on a regular basis and often take for granted are all parts of the study of statistics. This first screencast here is intended to be an overview of the entire course and an introduction to some basic vocabulary that will be used throughout the course. So if you notice here, there's two bubbles. We've got the descriptive statistics bubble here and this inferential statistics bubble here. These are representing the two branches of statistics, of classical statistics. You got descriptive statistics and inferential statistics. So we want to first start with descriptive statistics and eventually move into understanding inferential statistics. So the first thing, what are these things? Well, descriptive statistics is basically the study of summarizing data for the most part. For example, let's suppose you had 15,000 data points of students, college students across the country, and you had the data on their age. So you know the age of 15,000 students across the country, and you want to present that. You can't simply put an Excel spreadsheet in front of somebody with 15,000 data points in it and have them understand what's going on. You have to summarize the data in some way. So you could perhaps make something like a bar graph, things that you guys have seen for many years. You could make a pie chart, all kinds of different things that you can do. You could find the mean, or what many people call the average. There's all different types of computations or visuals that you can present that help people understand large sets of data. That is essentially what descriptive statistics is about. Inferential statistics is when you're trying to take that information you found. So imagine with those 15,000 college students that you found a mean age of 24.2 years old. I'm just making that up. I don't know if that's accurate or not. So suppose of your 15,000 college students, the mean age or the average age was 24.2 years old. But ultimately, we don't really want to make claims about those 15,000 college students. We want to make claims about the set of all college students, let's say in the US. So you're going to try to make a claim from those 15,000 students about the several million students attending college in the US. Anytime you're doing that sort of stretch where you're making a claim about the larger population, you are then working in the world of inferential statistics. So anytime you make a claim about a larger population from a smaller set of data, you are doing inferential statistics. And no matter what, unless you survey all of the college students, you can't be 100% sure that what you're saying is right. So if I want to claim that the average age of American college students is 24.2 years old, I'm not 100% certain that that is correct because I didn't talk to all of them. I only surveyed 15,000 of them. So no matter what, there's no chance I can be 100% certain that the average age of all college students is 24.2 years. I haven't talked to all of them. I don't have the time to talk to the several million college students in the US in a particular year. So I have to have a sense of what are the chances that I'm right. So for example, if I were to tell you I'm 5% confident that the average age of all college students in the US is 24.2 years, would you feel as comfortable with that as if I were to say there's 95% chance that the average age of all college students in the US is 24.2 years? Obviously, 95% confident sounds much stronger than 5% confident. Notice here that all these percentages I'm mentioning, these are examples of probability. So anytime you're working in inferential statistics and you start to make a claim, you have to have a probability attached with it. So notice here, you've got this descriptive statistics bubble, and then we have the inferential statistics bubble, but we can't go from descriptive to inferential without crossing this probability bridge, if you will. So we have to study probability in order to study inferential statistics. And descriptive statistics is in Unit 1 of our course. There are 4 units in the course. Unit 2 and the beginning of Unit 3 is about probability, and then the rest of Unit 3 and all of Unit 4 is the study of inferential statistics. Let's now get into some of the basic vocabulary that we need. So first, 4 key words here we need to establish: the difference between a population and a sample, and the difference between a parameter and a statistic. The population is the set of all possible data points that you're interested in understanding. So, for example, let's say we want to figure out what percent of high school students vape. Then the population in that study would be the set of all high school students across, let's say, all across the United States. But of course, we would not be able to talk to all high school students in the US since there's so many. So instead, we have to settle for a sample of the population. A sample is a subset of the population. So instead of surveying the millions of high school students across the entire state or across the entire country, perhaps we collect a sample of 10,000 high school students across the country, and then we study those 10,000 students. That's an example of a sample. So your population is the entire set of data that you're interested in, and your sample is a subset of that you actually use to do your computations and so on and so forth. Once you do computations, any computation that is done from a sample set of data is called a statistic. So let's say that 24.2 years in the previous example, that's an example of a statistic because from the 15,000 students that we surveyed, the average age of those college students was 24.2 years. The reason that 24.2 would be considered a statistic is because we did not survey all possible college students. If we had surveyed all possible college students, then we would know a parameter. So parameters are computations associated with populations, and statistics are computations associated with samples. And an easy way to quickly remember this is statistic goes with sample, S&S, and parameter goes with population. So let's now take a look at a few examples where we have to distinguish between a population and a sample, and between a statistic and a parameter. Number 1 here, suppose you want to find what percent of American high school students vape. You survey 500 students across the nation and find that 20% of them vape. We want to write down what the population is and what the sample is first. So who are we interested in? Are they interested in me? So for example, do they want to know if I personally vape or not? No, because notice they want to know American high school students. I haven't been in high school for decades now at this point. So the population here, and this is a key quantifier, is this word, all. All high school students are who they're interested in making claims about. All high school students. But of course, somebody doing that research can't talk to all the high school students. There's simply too many. So instead, what did they do? They surveyed 500 students across the nation. The sample is that set of 500 students that they surveyed. So the sample is the set of 500 students that they surveyed. So the population is a set of all high school students, that's who they're trying to understand, but they can't talk to all of them, so they settle for a set of 500 students. Those 500 high school students are a subset of the larger population. Now, there's also something in here where it says they found that 20% of the students vape. Is that 20% a parameter or a statistic? Did that computation, so 20% is 1 in 5, did that come from the sample data or population data? Well, this is where it came from. It came from these 500 students. Since it came from these 500 students, These 500 students make up the sample. That means this must be a statistic. So among those 500 students, 20% of them vape. However, that may not be the population parameter because we did not survey all of them. However, we're hoping that 20% is a good approximation of the population parameter. We'll talk about all that sort of how do we know if it's a good approximation or not in the coming screencasts. Let's take a look at number 2. As of the suspension of the NBA season due to the coronavirus pandemic, NBA.com reports that James Harden is the leading scorer with 34.4 points per game. Is that 34.4 points per game likely a statistic or a parameter? So I think they played about 62 games, roughly, before they had to shut down because of the coronavirus. Do you think they took 30 games, found how many points he scored in each of those, and then found the average? Or do you think they took all 62 games worth? It's likely that they took all 62 games worth. Why not? 62 numbers is not a very large set of numbers. So they likely computed the average of 34.4 points from all 62 games. The set of points that he scored in all 62 games suggests that this is a parameter because they didn't look at a subset of the population. They looked at the entire thing. In all his 62 games that he's played, James Harden on average scored 34.4 points per game. So this is most likely a parameter. Number 3, your professor says the average score on the final exam was 81%. Is 81% likely a statistic or a parameter? So let's say there's 25 people in the class. Do you think if I want to report to you guys what the average is on, say, test 2, do you think I'm just going to use, say, 15 of you and find the average among those 15? No, because 25 people is not a lot. And Excel can do quick computations with just 25 points of data. So it's highly likely that your professor is telling you a parameter because he or she is using the set of all data points, all the test scores. Whereas if I had 25 million students, then I'm not going to be able to give you the average of all of them. I would have to use a subset of that and compute the average score from that subset, which is what we would call a statistic then.